So this is rational exponents with powers. So we already know that the rule is if you have a squared to the power of 3, that we multiply these two to get 6. So that's all we do here as well. This is 2/3 times 5/3. And with multiplication, you just multiply straight across. So that's 10/9. That's it. So this one would be z to the negative 2/5 times 1/3. So that's z to the negative 2/15. These are my favorite because they're nice and quick. But you can't have a negative, so we take it to the bottom. Okay, one more. What if you have a whole number? Well, then when you write it, you just put a 1 under it. So that would be 14/3. Alright, so let's try it now if you have more than one factor in here. So the rule is that we're supposed to distribute this to every single exponent. So this would be x to the negative 3/5 times 5/2. And then we have y squared times 5/2. Let me put this in green so we can kind of differentiate the two. So I'm going to write them all out first. And then we would multiply this one by 5/2, this one by 5/2, and this one by 5/2. And that means we just reduce first. So 5 cancels 5. That 5 cancels that 5. That one reduces and gives us 2. Put this one under 1. That one also cancels. So let's write what we have left. And that would be x to the negative 3/2, y to the 5, and z to the 2. And this one we cannot have, so we draw a border, leave our positives on top, and take our x to the negative exponent to the bottom. And there it is. Alright, what if there's numbers inside? Well, if you can simplify them, we should. And then now when we square everything, we have to square everything. So that would be 64, x to the negative 6, y to the 10, which gives us 64 y10 over x6. And the same rule applies if you have rationals. So give number 7 a shot, and then we can apply this even more. Alright, you should have gotten x to the 15 and y to the 28. So if we distribute the 35 to each, put a 1 under it, we can reduce, and that leaves us a 15 and a 28. Alright, so what if you have just radicals? Well, you can rewrite them, and now we can use the rules that we have for multiply, divide, and for powers if necessary. So this would be 2x to the power of 6/8. And that allows us to reduce it. And now we get 3/4. So we can leave it in this form, or we can put it back like that. But it's still nicer than what we had before. And this little thing, that's a to the 1/6. That's our inside, and we just keep working our way out. That's 1/2. That's where these come from. So now we use the multiplication rule. And that gives us a to the 1/12. So it would really look like this. But either of them are fine. Alright, so this one would be a to the 1/2 to the 1/2, and then we just keep going, 3, -4. So all I've done is taken the square root of a and made it 1/2, taken that root, put a parenthesis and a 1/2, and we're going to work our way out. So this is multiplication. So that's 3, and working on the two inner parentheses, we get a, 1 times 1, 2 times 2, and -4. So we use the multiplication rule, and now we can use our exponent rule, which means we distribute to every single one. So this would be 3 to the -4, and then a to the 1/4, times negative 4. Put a 1 under it so we can multiply it. That reduces, so we get 3 to the negative 4, and then a to the negative 1. Draw our border because they're both negative, so that's 1 over 3 to the 4th, and then a. And if we want to, we can expand the 3 to the 4th to make 81. And that's everything. So that messed up looking thing, after using all these nice little exponent rules, turned into that. Thank you.